All right, yesterday we looked at quadratics and finding the vertex. Today we're going to look at solving quadratics by the graphing method. When you have a quadratic equation in this form, ax squared plus bx plus c, remembering that a, b, and c are coefficients, are going to actually be numbers in there. We can always look to find the solutions of one of those equations, and there's three possibilities. One is that you end up with one real solution. By solutions, we mean how many times it crosses the x-axis. So one real solution would be where the vertex is actually the only point that hits the x-axis. That would be the one solution. So the one solution would be that point. You might have a parabola that hits twice. If it hits the x-axis twice, then we say that there are two solutions. So both those points would be solutions to the problem. The last situation that could happen would be that the parabola's vertex is above the line and it's opening up and doesn't hit, or that the parabola's opening down and it's below the x-axis and also doesn't hit. Because it never hits the x-axis, then we say there is no real solutions. Okay, so when you put it equal to 0 and graph it, that's what you can get. So we're going to look at that today and look at some of those types of problems where we're going to be doing some graphing. So we have on number 1 the equation x squared plus 6x plus 8 equals 0. First, we're going to find some stuff out about from yesterday, and then we're going to see if we can find where those where their parabola crosses the x-axis, where our zeros are. From yesterday, the y-intercept we talked about, that's your c value. If you're graphing with a, b, and c as your coefficients, the c one is your y-intercept. So here that would be 8. 8 would be our y-intercept. Our vertex, we can get that with our little negative b over 2a equation. So if we put in our b and a values, b being 6, and a in this problem being 1, since we don't have a number in front of x squared, and simplify it, we get negative 6 divided by 2, which is negative 3. So our vertex is negative 3 something. Our axis of symmetry would also be at negative 3. So we know our parabola is going to be symmetrical about that line. All right, we want to finish out though and look at this one by graphing. So we want to come up with a table of values that we can use. Negative 3 would be the point we'd want in the middle here, because we know at negative 3, our vertex, it's going to be symmetrical about both sides. So pick some numbers that are bigger than negative 3, like negative 2, negative 1. Some numbers smaller. Well, let's find these out. Now you can plug those numbers in to this and find them out just doing it by hand. For example, if we plug negative 3 in here for each thing, negative 3 squared plus 6 times negative 3 plus 8, and see what that equals. That would be 9 minus 18 plus 8. And if you solve that out, you end up getting negative 1. So you can just go through and do it by hand. The quicker way, though, we would want to use some type of graphing utility to get our graph. So I'm going to use the graphing calculator here to do that. So enter your equation, x squared plus 6x plus 8. We could definitely take a look at the graph. Let's bring up our table, though, so we know where the points are. And we said we want to have this kind of centered around negative 3, so we have some numbers here. All right, so putting those numbers in at negative 5, we see it's 3, at 4, 0, negative 2, 0, and so on. So filling in our table here, we have 3, 0, 0, 3. So now we got some points over here we could graph out and see what our parabola looks like. So negative 5, 3 is there, negative 4, 0 is here, negative 3, negative 1, there's our vertex, negative 2, 0, and negative 1, 3, and that is our parabola. Now, we want to also answer on this one. This is kind of new, something we didn't do yesterday. What are the zeros? Remember, zeros, that means the same as solutions. Okay, the zeros are solutions. Another word you're going to hear for this is also sometimes called the roots. Basically, what it means, though, is where does it cross through the x-axis? Where are the x-intercepts? All these things mean the same thing. Okay, so where did this one cross through the x-axis at? There's 2 points on this one, at -4 and at -2. So those are the 2 points, -4 and -2. Those are the 2 zeros, or the 2 solutions. All right. Now, you can also use calculator to help you find these out too. On most graphing calculators, you're able to do that. If we go back to our graph here and graph it out, you usually can use some type of analyzing the graph button, or on this calculator, if you go to calculate, which you hit second trace and go to the calculate menu, one of your options is zeros. So if you want to find the zeros, you can go to that. And then select near your point where it would be. Here they want us to select a point to the left of where the 0 is. So put your cursor to the left. They also want you to find a point to the right of where it crosses, and then hit enter again, and it'll tell you, yep, one of them's -4, 0. You could do it again to find the other one, so select 0 again. This time select a point to the left of the other intercept and a point to the right. Hit enter again, and you can find them that way too. So calculator does help you find those on the graph as well. All right, for tomorrow, I want you to try out number 2 here. Now, one thing you might want to do when you're doing this problem to help you out a little bit is maybe solve this one and get it equal to 0 first. So get it in that form, ax squared plus bx plus c before you do it, and then see if you can graph it out and find that one. All right, why don't you go to the back. Let's take a look at number 3. On number 3, they want us to kind of find a lot of the same stuff again. So what's the y-intercept? What's the vertex? What's the axis of symmetry? Well, our y-intercept would be -1, like we did on the last problem. That's this number right there is going to be our y-intercept. Our vertex, we can use our little equation again. X equals -b over 2a. So here that would be -4 over 2. Our a on this one is -1. And that's going to give us -4 divided by -2 would be +2. So we have our axis of symmetry is going to be x equals 2. We also know our vertex is 2 something. To find that, you want to bring up the table. Let's use calculator to graph this one and get our table as well. So this one is -x² plus 4x minus 1. There's the graph of it. We can see it opens down, and it should open down because our a value is negative. Anytime our a value is negative, it should open downwards. All right. If we go to our table, we know that our x equals 2 is going to be our vertex. So if we're looking at our table here, we want 2 kind of in the middle. That's our vertex. So let's pick some numbers bigger, some numbers smaller, and fill in our table here. So if we scroll down a little bit, let's get kind of 2 in the middle. All right, there's some numbers. So filling in our table, we have the numbers -6, -1, 2, 3, and it's symmetrical. So 2, -1, and -6. It should be symmetrical on both sides. These should be the same. Those should be the same. Those should be the same because it's symmetrical. All right, so let's plot those points on here and see what get our parabola on our graph. Our parabola, we got -1, -6 is there, 0, -1, there. 1, 2, 2, 3. That's our vertex. And then it's symmetrical, so it should have the same points on the other side. So there's our parabola. All right, now should do something like that. All right, there's our parabola. And we have our axis of symmetry. We knew our axis of symmetry is at x equals 2. All right, so we have all our information on this one now. Now the last thing we want to know, where are the zeros? Zeros mean where are the intercepts. Now on this one, it's a little bit different than what you've seen on the first two. If you look at where it crosses through the x-axis here and here, it no longer is right through a whole number. It's kind of in between. We got a zero somewhere between 0 and 1. There's also another one somewhere between, looks like 3 and 4. So how do we find those? Well, as we go throughout this chapter, there'll be some other methods we can use to find out exactly where those are. The graphing method doesn't work so well for ones that don't land on whole numbers like this. But if we use what we talked about with your calculator, we should be able to approximate where those are. So if you go on your calculator, if we go back to our graph, we can again go to our calculator, analyze graph. If you're using a TI Inspire, find where your zeros is, and you should be able to estimate a little better where that is. So pick a point to the left of the intercept, pick a point to the right, and it looks like it's at about 0.2, we'll round that off, about 0.268. So that's where one of them is. And the other one, we could also find doing the same thing. So again, select zeros. We want to find the zeros. Pick a point to the left. Pick a point somewhere to the right. Keep hitting enter. And the other one's at about 3.732. So those would be the two zeros, or the two solutions to this one. All right. When you get back to class, we'll look at a couple of those last word problems on your sheet and go from there.